Many acids and bases react to form water. When equal amounts of an acid and a base react, the resulting solution is neutral. Knowing when a solution is neutral, that is, it has a pH of 7, is an important part of a titration. You may recall that the pH of a solution is a measure of the concentration of hydronium or H3O plus ions in the solution. Acidic compounds have a pH less than 7 and a very high concentration of hydronium ions, while basic compounds have a pH greater than 7 and a very high concentration of hydroxyl or OH minus ions. Part 1. Testing 3 methods of measuring pH. There are several ways to determine the approximate pH of a solution. Litmus paper turns red in the presence of an acid and blue in the presence of a base. A pH indicator, such as the universal indicator, turns a specific color based on the solution's pH. When more precise values are needed, a pH meter after calibration, along with the graphical analysis app, will provide specific pH values. In order to compare each of these methods, we will determine the pH of 3 common household chemicals, namely vinegar, baking soda, and tap water, by using litmus paper, universal indicator, and a pH meter in Part 1. The sample result table for Part 1 is as follows. It includes the substances which we study here, the observations using all the 3 methods, and the final conclusion as to whether the substance is acidic, basic, or neutral. As you see the video of the experiment, you can also understand which method is more sensitive and which method is more accurate.
So again, this is one of the tables that you guys should have already written out before the lab started. And if you did you read the pre-lab, like the procedure, then you probably should already have had it written out. I'll give you guys a couple seconds to get it figured out. All right, I'm gonna go ahead and start it back up. Again, you'll need to be taking down notes over all this stuff. So.
In measuring the pH.
Okay, so in part 1 of this lab, we're going to be determining the pH of 3 different solutions using 3 different methods. So the 3 different solutions we have are vinegar, which is in this beaker. We have baking soda, that's been dissolved in water here. And then we have just normal tap water. So the first method that we're going to be using to determine the pH are these red and blue litmus paper. So red litmus paper will stay red if it's been exposed to acidic solution, but will change to blue if it's been exposed to a basic solution. Blue litmus paper is the exact opposite, where it will stay blue if it's been exposed to a basic solution, and will turn red if it's been exposed to an acidic solution. So vinegar is going to be the first one done. And so if I just put this in here, you'll notice that no color change happens. Then we'll do the same for blue. And you'll see that that blue changed red. This tells us that vinegar is an acidic solution. Next up, we'll do baking soda. So we'll get another red litmus paper and put it in here. So that changed slightly blue, suggesting that it is a basic solution, but just to confirm, we will also do it with another blue piece of litmus paper. And so that also stayed blue, telling us that baking soda is in fact acidic, or I'm sorry, basic. Finally, we have DI water, or I'm sorry, this is tap water. And tap water should be close to neutral, so that stayed red. And then using the blue litmus paper, this stayed blue, indicating that this solution is close to neutral. Yeah. Okay, so the second method that we're going to be using is a pH meter. So what this does is at the very end of this instrument, there is basically a measuring device that can directly tell us what the pH value of each solution is. So first we'll put it in the vinegar. And so this is connected to an app called Graphical Analysis that's on my phone. And as you can see, the pH of this solution is going to be around 3.5, which means that this is acidic. So after doing that, all I need to do is put this into a new solution. First, I want to wash off that vinegar into a waste beaker. And now I can put it into the baking soda solution. So if you look at my phone, you can tell that the pH quickly went up and is now adjusting to the pH of this baking soda solution. And so as you see, the pH keeps going up and up, indicating that this is likely a basic solution. So it looks like the pH of this is about 8.1. And then finally, we can wash this again to get rid of that basic solution. And then put that back into the DI water, or I'm sorry, tap water. And so, as we suspected that this DI water is close to neutral, it looks like it's on the low side, slightly acidic. So 6.91. Okay, and that's the second way to measure pH. Okay, the third way that we're going to be measuring pH today is using a universal indicator and then checking the color of the indicator in the solution with this chart. So hopefully you guys have seen something similar to this before in lecture, but basically what it is, red is on the acidic side of things, so at 4.0 the solution should turn completely red, and then basic at pH of 10 is going to be a dark blue or purple. So what I'll do now is just add a few drops of this indicator into each solution. So as you can see, that turned a red color. Now we'll go over to the baking soda. A few more. That is looks like a dark green. And then finally, the tap water. So that looks to be a lighter green color. So if we go back to this chart, we could say that the pH of this acetic acid or vinegar is close to 4. The baking soda close to 8 or 7.5, and then finally this tap water about 6.5. And that's how you determine the pH of solutions.
Part 2. Standardization of sodium hydroxide. Sodium hydroxide is hygroscopic in nature, meaning that water will adsorb to the surface of the solid sodium hydroxide pellets that was used to create the reagent solution. A primary standard that is not hygroscopic, like potassium hydrogen thalate or KHP, is used to make solutions for which accurate molarities can be directly obtained by taking a mass of KHP and dissolving it in water. The reaction during the titration is as follows. The experimental setup includes the burette, which will have sodium hydroxide solution of unknown concentration, a beaker, which will have 0.3 to 0.6 gram of KHP accurately measured, 50 milliliters of boiled DI water to ensure that the KHP has completely dissolved, and 2 to 3 drops of 1% phenolphthalein indicator, which is the reason we see the pale pink color during endpoint. The titration ends when the pink color persists for more than 30 seconds. The initial and the final volume on the burette is noted down, and that is used for the calculation.